Azure says a very simple promise: you pay for what you use. But in reality, most teams aren't paying for what they use. They are paying for what nobody shut down, what nobody claimed, and what nobody even remembers is still running. An idle VM keeps billing, an orphaned disk keeps billing, a stale test stack keeps billing. Even a forgotten workflow piece adds to the cost because the meter doesn't care if your project ended. It only cares that the resource still exists. And this is where manual governance breaks. Cleanup depends on memory. It depends on spare time. It depends on someone noticing a report after the spend has already landed. Then the meeting starts. Finance sees the number. Engineering checks old tickets. Everyone tries to figure out who owns the mess. That model doesn't scale. So in this episode, we are building a different one. Azure Policy sets the rules, tags carry the context, and Logic Apps turns that context into action. The result is a cleanup engine that finds resources with no valid reason to live and removes them safely. Because if governance stays manual, waste scales faster than the team. Why cloud waste keeps surviving? Most people treat cloud waste like a sizing problem. They think a VM is too big, or a database tier is too high, or a storage setting costs more than it should. While those things are real, they aren't the full pattern. A lot of cloud waste survives for a much simpler reason. Resources keep living long after the work that created them is gone. That is lifecycle drift. A project starts fast because the cloud makes starting easy. A dev team spins up a sandbox, or someone runs a proof of concept, or a temporary integration gets built to test an idea. Then priorities shift and the sprint ends. The owner changes or the team moves on. The work stops, but the resources do not. And because the cloud is good at staying available, it is also very good at staying expensive. What typically happens is this: the ticket closes. The engineer who built the environment joins another team. The manager assumes the cost belongs somewhere else. Finance sees the spend, but they don't see the intent. The environment just sits there. Each month, it looks less like an active decision and more like background noise. That noise grows when tagging is weak. If a resource has no clear owner, no environment tag, and no expiry date, then your cost data loses its shape. You can see the bill, but you can't see the story behind the bill. This is why untagged spend matters so much. When tagging discipline is poor, industry patterns show that 20 to 30% of cloud spend often falls into unallocated territory. It isn't hidden from Azure, but it is hidden from accountability. And once accountability gets blurry, cleanup slows down. Manual review sounds responsible, but it creates a massive delay loop. Someone exports a report, another person filters by service, and a team lead asks engineers if anything can be removed. People reply late because they are busy doing actual delivery work. A week passes, or maybe two, and during that time, nothing changes except the bill. Delay protects waste. Engineers are usually great at optimizing the things they are actively building. They care about performance, deployment speed, and reliability. But almost nobody wakes up excited to hunt for a forgotten sandbox from 3 sprints ago. That work has no momentum and no visible product outcome, so it slips. And one level deeper, this isn't really a tooling failure. Azure already gives you policy, resource graph, and cost management. The platform isn't missing controls, the model is missing enforcement. In most organizations, governance still sits outside the delivery path. Teams build first, and then governance inspects later. But by the time later arrives, the waste already exists. The issue isn't that people don't care. The issue is that the system asks people to remember lifecycle decisions in an environment built for speed. That assumption is broken. What works better is a control model that starts earlier. You need a system that captures intent when resources are created, keeps that intent attached through tags, and checks continuously whether the resource still deserves to exist. Once you see that, the next question isn't who forgot the cleanup. It's what the engine needs to decide for them. The governance model behind the engine. So what does this engine actually need to be? Keep it simple. You only need 3 parts. Policy is the law, tags are the context, logic apps are the action. That distinction matters because most governance designs fail by mixing all 3 together. They try to make policy decide every outcome, or they turn automation into a massive script full of hard-coded exceptions, or they let tags grow into a messy dictionary that nobody trusts. When that happens, the system becomes impossible to explain, difficult to maintain, and very easy to bypass the moment pressure goes up. It starts with policy. Policy decides what metadata must exist, where it must live, and how it should be inherited. It isn't the cleanup engine itself, it is the rule layer that makes the cleanup engine possible. In practice, this means policy checks if resources carry the required tags, ensures those tags come from the resource group when they should, and stops new deployments from proceeding without the minimum context attached. The sequence of how you roll this out is everything. Audit first, then modify, then deny. Audit gives you visibility without breaking teams on day one, which is useful because most estates already contain years of drift that you can't fix overnight. Modify lets you remediate those existing gaps through remediation tasks and inherited values, and then deny comes much later once people know the contract and the deployment path is ready for enforcement. You want to apply that model high in the hierarchy. Management group scope comes first, because subscription by subscription governance falls apart the moment the estate grows. Teams create their own variations. Owners change settings. One subscription gets a stricter policy set while another gets left behind, and soon your control model depends on local habits instead of shared standards. A management group assignment gives you one operating rule that flows downward to everything. Inside the subscription, resource groups do the heavy lifting. This clicked for me when I stopped thinking about resource groups as folders and started treating them as lifecycle boundaries. This is where most resources share the same owner, the same environment, the same cost center, and usually the same retirement pattern. Inheritance from the resource group catches a large part of the estate without forcing every deployment team to tag every single child resource manually. There is one hard limit you have to keep in view. Azure Policy can enforce rules within subscriptions, but it doesn't natively enforce tags at the exact moment a subscription is created. Don't design a fantasy system. Design the one Azure actually supports. Put subscriptions under the right management groups, apply your policy there, and use post-creation audit and automation to catch what the platform doesn't do at birth. And keep the tag model tight. Azure supports far more tags than you should ever use. Just because you have the slots doesn't mean you should fill them. If the engine's purpose is safe cleanup, then your first tag set should focus on deletion decisions, ownership, and exceptions. Once teams trust the model, you can expand for reporting or broader governance. But if you start with 20 tags, people will find ways around the process before the engine ever earns its credibility. The model is small by design. Policy creates the contract. Resource groups spread that contract through inheritance. Management groups keep the contract consistent at scale. Logic Apps then reads that structure and acts on it in a repeatable way. This isn't because automation is smarter than people, but because it is better at checking the same rule every single time without getting distracted by sprint pressure, team changes, or someone's half memory of why a resource was created 6 months ago. Now that the model is in place, the next part gets very practical. We need to look at which tags actually let the engine decide what can be deleted, what must be left alone, and what needs a human in the loop. The tagging system that makes deletion possible. Now we get to the part most teams either overcomplicate or treat like admin trivia. Tags are not decoration. They are the minimum context your engine needs before it can take action without guessing. Start with the mandatory set. You need owner, environment, cost center, and an expiry date or a TTL model. You also need cleanup action and exception reason. That list is short on purpose because every one of those values answers a specific deletion question. You need to know who owns the resource, what kind of environment it is, and which budget it belongs to. You have to know when it should stop existing, what should happen at that point, and if it must stay, you need to know why. You can add more, but only add them for a specific reason. Workload name helps when one team runs several apps, and data classification matters if the engine needs to avoid sensitive workloads. Criticality helps with routing and approval logic. Created data is useful too, but don't build your model around age alone because age is a weak signal. An old resource can still be valid, while a brand new one can already be waste. Age tells you the duration, but it doesn't tell you the intent. Expiry date tells you the intent, or TTL does, if your process calculates an expiry from the day of creation. That is the difference between passive reporting and lifecycle control. The tag doesn't just describe the resource, it declares the resource's expected end. Owner is equally important, and it isn't just for showback. If the engine wants to notify someone, request approval, or prove that nobody responded before deletion, it needs a real owner path. Team names can work if they map cleanly to an operational queue, but freeform names like the platform guys do not. Cleanup action is where the automation becomes explicit: delete, notify, quarantine. Ignore if you really must. Whatever values you choose, you have to standardize them early. The same goes for environment values like dev, test, and prod. Pick the set and hold it. If one team writes production, another writes prod, and a third writes live, your workflow turns into text cleanup instead of governance. Exception reason needs that same discipline. Use it to protect shared platforms, regulated systems, freeze periods, or short-term business holds. Don't use it as a lazy escape hatch with values like temporary or do not touch. If people can write anything, they will. Once free text enters the system, your automation stops trusting the data. Inheritance matters here more than perfection. Apply tags at the resource group where lifecycle context usually starts, and then inherit them down to child resources with policy. That gives you broad coverage without turning every deployment into manual tag entry. For older estates, you can use modify policies with remediation tasks to fill gaps instead of waiting for a full rebuild. Then you tighten the screws. Start with modify because it repairs the environment. Move to deny only when teams know the rules and the pipeline supports them. If you deny too early, people will blame governance for their problems, but if you deny after the model is clear, it just feels like a normal part of the process. You also need a recurring audit, and Resource Graph is the right tool for that. Run it weekly. Look for missing tags, bad values, expired resources that are still alive, and resources whose tag pattern no longer matches the resource group that contains them. If you remember one thing here, remember this. Deletion only feels dangerous when the context is weak. Strong tags turn cleanup from a risky guess into a controlled decision. Once that context is reliable, the workflow can finally do the part people keep postponing. It can act, building the logic app cleanup flow. Now the workflow needs a place to live, and for most teams, the best starting point is logic app's consumption. It isn't that the standard version is bad, but this engine should stay cheap when nothing is happening. Cleanup volume usually changes from week to week, and the consumption model handles that naturally because there is no fixed monthly floor just for existing. You pay when the engine runs, so if it barely runs, it barely costs. That matters for governance automation because the whole point is to remove waste, not to introduce a new always-on platform bill before you've even proven the value. Set the trigger on a schedule. Off hours usually work best, especially for non-production cleanup, because the workflow can scan and delete with less risk of hitting active changes. This still gives teams a predictable window they can plan around. Scope it from the top where possible, like a management group if your estate is mature enough, or a subscription if you need to start smaller. The important part is consistency, not being overly ambitious on day one. The first real action is discovery. Use Azure Resource Graph to query for candidates like expired sandboxes, unattached disks, or resource groups tagged for cleanup. You want the workflow to build a candidate list from the actual state of the environment, not from a spreadsheet somebody exported last week. Once discovery becomes a manual task, the engine is already drifting away from the environment it claims to govern. From there, the flow turns into decisions. Take each candidate and filter it through a small decision path. First, exclude protected workloads based on environment or criticality tags, then validate that the required tags are present and usable. After that, inspect for locks and check whether dependencies exist that would break the deletion order. Only then should the workflow move to the action branch. That sequence is where most people cut corners. They jump from the query straight to the delete action because the query looked clean, but a good query only finds candidates and does not prove safety. The workflow has to do that proof step by step. Because each Azure resource behaves a little differently, the flow should branch by resource type instead of pretending every deletion works the same way. A virtual machine is not an unattached disk. A network interface is not a stale resource group, and an old app resource may have child objects or service links that need a different delete path. Build type-specific branches instead. Keep the shared checks at the top, then split into smaller paths where the delete action and validation logic fit the actual resource you are dealing with. For authentication, use managed identity everywhere you can. That removes stored credentials from the design and avoids old patterns that create extra security debt. Give the identity the narrowest permissions the workflow needs at the scopes where it actually operates. The engine does not need broad rights across the entire tenant just to clean up stale dev assets, and every extra permission widens the damage if the workflow or its operators get misused. Start with the lowest risk targets first. Unattached managed disks are a good example, as are expired dev resource groups and temporary sandbox environments with clear expiry rules. Those are easier to explain, easier to test, and less likely to create political resistance. This matters because the first version of the engine is not just a technical rollout, it is a trust exercise for the whole organization. For medium risk cases, add a pause, send a notification to the owner tag, or create an approval path before deletion. That gives teams a chance to intervene without turning every cleanup into a service desk ritual. You want just enough friction to protect uncertain cases, but not so much friction that the process becomes another ignored inbox. Then log everything. Write deletions, skips, approvals, and failures into log analytics so you can prove what the engine checked and why it stopped. That audit trail is not just for admin comfort. It is the difference between controlled automation and a black box that people will shut off the first time something goes wrong. Add retry logic for transient errors, but be selective. If Azure returns a temporary failure, go ahead and retry, but if the workflow hits a lock or a policy conflict, you should stop and record it. Retrying the wrong kind of error just wastes runs and hides a design issue under a layer of noise. And this is why Logic Apps fits the job well. This isn't just one delete script on a timer. It is orchestration across discovery, validation, branching, and action. One workflow, many decisions. Deletion sounds straightforward until Azure pushes back, and that is exactly where weak designs collapse. What breaks automated deletion and how to design around it? The first thing that breaks automated deletion is usually not permissions. It is locks. A workflow can hold the right role assignments and still fail because Azure resource locks sit above those expectations. If a resource carries a cannot delete lock, the delete call stops right there. If that locked resource sits inside a broader cleanup path, one object can hold up the whole attempt while the rest of the run waits or gets skipped. So your engine has to check locks before it tries to be helpful. That sounds obvious, but lots of cleanup flows only discover locks after the delete call returns an error. By then, you've already burned a run and created noise in the logs, which teaches teams that automation is unreliable. Check first, record the lock, mark the resource as protected, and then move on. Dependencies are the next problem, and they are less visible. Azure doesn't just store resources, it stores relationships. A VM can still point to a disk, or a NICI can still sit under a machine that hasn't been removed yet. Managed services create child resources you didn't build directly, and some resources are owned by another service through a managed by property, which means deleting the child object directly may fail. This is where deletion order matters. You can't treat the estate like a flat list. Parent and child order has to be part of the design, especially for resource groups that contain mixed services. In some cases, the right answer isn't to delete the child at all. It is to remove the parent service that owns the rest of the stack. Then you hit soft delete and recovery settings. Some Azure services don't disappear the way people expect. They move into a recoverable state or keep data retention behavior after the initial delete action. If your engine reports success too early, the team thinks the cost and exposure are gone when they may not be fully gone yet. Design the workflow to distinguish requested deletion from completed deletion and follow up on the final state where needed. There is another trap higher in the stack. Governance can block governance. If inherited policy uses deny action or other restrictive controls, your cleanup engine may collide with the very rules your platform team put in place. That isn't a reason to weaken policy, it is a reason to map policy interactions before you turn on deletion. The engine should know which scopes are allowed and which policy paths require exemption handling instead of brute force retries. A safer design starts with exclusions, not ambition. Production, business-critical systems, and regulated workloads should be excluded first. Make the default cleanup set narrow enough that you can explain every rule to an owner in one short conversation. Broad automation sounds efficient, but broad automation without trust creates pressure to shut it down the first time someone gets nervous. And before live deletion, run dry. Dry run mode is one of the best ways to build confidence because teams can see exactly what would have been deleted and why. That exposes weak tags, hidden dependencies, and bad assumptions before anything disappears. It also changes the conversation from fear to evidence. For uncertain resource classes, use quarantine instead of immediate deletion. Move them into a tighter review state or apply a temporary control path that flags them for an owner response. This works well when confidence is moderate, but not strong enough for direct removal. It buys safety without falling back into endless manual review. Keep exceptions simple too. If the exception process takes weeks, people will stop using the system properly and start inventing ways around it. A short, visible path with clear reasons works better than a heavy approval maze. On the security side, keep the managed identity narrow and fully auditable. Give it only the roles and scopes the engine needs and nothing wider. When deletion fails, don't treat that as random noise. Failed deletions usually expose something useful, like broken ownership, bad architecture, or unmanaged dependencies. The failed run is telling you where the environment still doesn't understand its own life cycle, measuring whether the engine is actually working. Once your workflow goes live, the first thing most teams look for is a savings number. That number matters, but it is too small on its own. Reclaimed cost only tells you what got cleaned up after the waste already existed. A mature engine should do more than that. It should reduce the amount of waste that ever appears in the first place. That is why you need two views. The first view is reclaimed cost, which tracks what the engine actually removed from the bill. The second view is prevented cost, which you can track through an effective avoidance rate. This second view asks a much better question. It asks how much spend never landed because your system enforced discipline before drift turned into waste. One measures cleanup, the other measures behavior change. Then you need to check your tag quality because savings without context will eventually fool you. Track the percentage of spend attached to valid tags. Separately, track the percentage of deletable resources that still have a clear owner path. If the bill is getting cleaner, but ownership is still vague, you haven't actually fixed the operating model. You have only cleaned up a few visible leftovers. Workflow health belongs on that same dashboard. You need to look at run success rates, failed runs, and the mean time it takes to fix things. But pay special attention to skipped resources. Skips matter more than people think. They show you where the engine sees risk, where it lacks context, or where it hits a rule it cannot resolve on its own. A low failure count looks good on a slide. But if your skips keep rising, your estate is just pushing uncertainty back into the process. Watch your drift over time. Do not rely on a static monthly snapshot. Compliance decays quietly. A single report can look fine while new exceptions and unmanaged deployments build up behind the scenes. Week-over-week patterns tell the real story. You need to know if unowned resources are shrinking and if expired assets are getting removed faster than before. Check if policy gaps are closing, or if teams are finding new ways to land resources outside the expected path. Different audiences need different proof. Executives want fewer billing surprises and cleaner chargebacks. They want to know if the cloud estate is becoming more predictable. Engineers want something else. They want fewer cleanup tickets and less background noise in the subscriptions they work in every day. If both groups feel less friction, the engine is doing more than just deleting files. It is improving how the platform behaves. You should also compare the cost of your automation against the manual effort you avoided. Even a lightweight workflow looks smart when you measure the hours it saves. It removes the need for chasing owners, checking old deployments, and cleaning simple resource classes by hand. The question isn't whether automation is free. The question is whether repeating manual governance is cheaper. In practice, it rarely is. And do not treat these metrics as a celebration deck. Use them to tighten the system. If one tag value causes repeated skips, you need to fix the taxonomy. If one resource type fails often, you need to narrow the scope or improve the logic. If one subscription keeps drifting, That is a management issue, not a workflow issue. Measurement should feed the next policy adjustment and the next expansion step. Success is not a pretty savings chart. Success is a platform where ownership is clear, drift is low, and the organization stops asking if a resource still belongs there. The right way to ship this is to start narrow. Pick one cleanup class first, like expired dev, resource groups, or unattached disks. A small scope teaches you more than a big design review ever will. Once the tags and the logic prove themselves there, the model becomes much easier to grow without any guesswork. Keep that first tag set small. Backfill with a modify policy. Block with a deny policy only after the contract is clear to everyone. Run the workflow in audit mode first, review the skips, and then turn on deletion when the evidence supports it. This is the shift. Stop treating cloud waste like a reporting issue. Start treating it like a lifecycle control issue. If this changed how you think, follow me, Mirko Peters, on LinkedIn. And if you want more of this, leave a review. It helps more people find it. Share this with your team, especially if you are dealing with this right now.